Welcome to Brain Vision.
Hello everyone, here it is given 18-inch radius flywheel. So radius of flywheel is given 18 inch. Is rigidly attached to a 1.5 inch radius of shaft. So radius of shaft is 1.5 inch. Both are attached together rigidly and shaft rolls along parallel to the rails. Shaft rolls along parallel to rails. As shown in the figure, the center of the shaft having the velocity 1.2 inch per second square, 1.2 inch per second, and acceleration. So I am drawing the cross-sectional view of wheel and shaft. Suppose this is the shaft and G is the center of it and C is instantaneous center of the wheel. So velocity of shaft I will write later on. So we have to calculate acceleration of point A and point B as shown in the figure. Calculate acceleration of A and acceleration of B. Let us start solving it. Let here G is the center of shaft. Let G is center of shaft. C is point of contact with the rail. Since shaft doesn't slip over the rail, so C is instantaneous center of center of center of the wheel. Since shaft is performing pure rolling motion, the velocity of shaft, center of shaft can be defined as omega into r. So angular velocity will be velocity of shaft upon radius. Velocity of shaft is given 1.2 inch per second and radius is 1.5. So it will be 0.8 radian per second in counterclockwise direction. Now we will analyze the acceleration. Acceleration analysis. Acceleration of C is AC in the direction 20 degree. Acceleration of G is given 0.5 inch per second square. It would be 0.5 inch per second square in the direction 20 degree. Acceleration of C can be written as acceleration of G plus acceleration of C with respect to G tangential plus acceleration of C with respect to G normal. Now we will write the value. AC is in the direction 20 degree. AG already we have written 0.5 inch per second square in the direction 20 degree plus tangential acceleration alpha into r. So 1.5 into alpha in this direction. Normal omega square r 1.5 omega square. I am writing here tangential acceleration is alpha into r. Normal acceleration is omega square r. So these property we always used, and direction are marked here. Keep in mind we are writing in vector form only. If we take component of all this equation along this direction as marked, if we assume this to be x-axis, then you will get 0.5 minus so alpha will be 0.333 radian per second square in counterclockwise direction. Now, part A. Acceleration of A, we can write acceleration of G acceleration of A with respect to G in tangential direction and acceleration of A with respect to G in normal direction. This value you know 0.5 inch per second square in this direction plus 18 into alpha towards left plus 18 omega square downward to the right. Alpha you know 0.33 towards left. Omega, we have calculated 0.8 radian per second square. So we can write acceleration of A to B point 0.5 cos of 20. If we writing the direction negative is not required, plus 0.5 sine of 20 downward. This can be written as 0.171 towards left, sorry, I have to make a correction here. Then this can be written as 6 towards left plus 11.52 downward, and unit will be inch per second square. So on simplifying, acceleration of A we will get 6.48, sorry, 6.4698 towards left plus 11.670 vertically downward. So this is the answer of part A. Now part B, acceleration of B point. Acceleration of V can be written as acceleration of G. Acceleration of V respect to G tangential direction. Acceleration of V with respect to G normal direction. This value you know, 0.5 in this direction. This is 18 into alpha towards right. This is 18 into omega square in upward direction. This could be written as 0.5 cos 30 towards left. 0.5, we are resolving it, 0.5 sin 30 downward direction. 18 into 0.3333 towards left, right, sorry, 18. Omega is 0.8. So solving this equation, you will get acceleration of V point to be 6.4698 towards left plus 11.670 in downward direction. Sorry, you will get in upward direction. So this is the answer of B part. I have noted down wrongly, so I am writing again. Just a moment, please. Bear with us. It is 0.4698 towards left. I'm again doing the mistake. Just a moment, please. This plus solving this and this, you will get 5.53 towards right, and solving this and this, you will get this and this, you will get 11.349 in upper direction. So this is the acceleration of B point. That's all for this problem. Thanks for watching it.